First of all, if we take a look at how much funding is used in education, it is a fairly large enterprise, as you can imagine. But then if we take a slice of that and look at how much of it is being used in STEM education, and particularly if you look at that chart, the amount of funding that's used for K through 12 STEM in federal agencies is about 0.1% of the budget, and that compares to K through 12 federal spending on all of education, which is 5.9%. Now, if we go to the next chart, if we look at the breakdown of funding in STEM education at the federal level, first of all, you see that National Science Foundation and Department of Education have the larger share, and of course there's no surprise there. And there are many organizations, or rather many agencies, that do participate in K through 12 education. Next one, please. Now, that's all very good news. So there is a fair amount of funding provided by the federal government on STEM education. And these funding are used for science education, for agency-specific, which means workforce development, and also for STEM education as a whole. If we look at how much is being used for engineering specifically as compared to how much is used for science specifically, you can see that the amount used for engineering directly is extremely small. And so that's what brings us over here. Why do we need to talk about engineering? Well, let me first define for you and make a distinction between science and engineering. One definition of science is that it's a systematic study of the structure and behavior of the physical and natural world through observations and experimentation. Basically, science helps us understand how the world works. Engineering, on the other hand, is application of the scientific principles along with mathematics to solve real problems that would help the mankind and improve the quality of our life. In engineering, we use the processes of innovation, analysis, design, evaluation, manufacturing, and so forth to make a product. And that product is then called technology. So that's the distinction between engineering and technology. Technology is the result of science, math, and engineering. Now, the process that's used in engineering for defining the problem, analyzing the problem, coming up with an innovative solution, and considering all the constraints that are imposed on that solution, that process is extremely important because that same process can be used in almost any, to solve almost any problem. That process can be used even here in Congress to really understand what the problem is and come up with a solution. That's why we think that it's important for engineering to be taught at K through 12 systems, not only to encourage students to go towards STEM and engineering in future, but also to give them a tool so that they can analyze, they can understand and analyze problems and come up with solutions. They can apply that to almost any situation. So that's why we're here today. And with that introduction, first I want to thank our panel members. And I have to tell you that we are really honored to have them here. These are a group of people who are actually out there. They're actually in the classrooms, with the exception of James. And they have been out there teaching engineering, teaching STEM-related subjects, and they've been doing it for a few years. I'm not going to tell you how many years, but they have the experience and they know what they're talking about.